Hi everybody. Let's see here. Getting back on track now with the thin film interference topic. We're in chapter 24, and right now we're going to be talking about stuff from section 24.3 is really where this lecture comes from, not so much 4. Okay, so section 24.3. And I want to say a little bit more about what we talked about in the last video, which is this idea of phase shifts. It's really important when we're adding two waves. Remember with double slit interference, the Young's double slit experiment, two waves, one wave left slit 1, the other wave left slit 2, and they added on the screen. Okay, they added on the screen. And so we're adding waves. So this is what we mean by adding waves. I'm going to do it two different ways. Okay. Here's a wave. It continues on both directions. That's what the ... business means on both sides here. Pardon me, my eye's a little bit, I think it's allergies messing on my eye. Anyway, there's the wave, ... And this thing is, of course, moving, but we'd have a snapshot in time here. And if we take that wave and put another wave on it, let's add another wave, which really lays on top of this one. Okay, so there's another wave. We've got the green one, and now we're adding to it the kind of pinkish one. ... So we add those two waves together. The pink shows up okay, I guess. What you get is a new wave. And right at every point along the x-axis, here's the x-axis, of course you recognize it. There's y, x, y, x, x, y. At every point along the x-axis, all we have to do is add the waves. So what happens when we, add the waves together is that we have, in this case, constructive interference, because when we add the waves, you have positives on top of positives and negatives on top of negatives. And when you add positives on positives or negatives on negatives, you get constructive interference. So if the amplitude of these waves is A, then what you get is a wave like that. Those peaks are supposed to line up with peaks and troughs with troughs, so that now we have an amplitude of 2A. This is constructive. So when the waves are in step and they add up, you get a bigger wave, right? Which is what interference is. Constructive interference is. Now suppose we're going to take this pink wave now, the pink one, the one that I added, and we are going to shift it by 1/2 of a wavelength. Okay, remember the wavelength is this quantity right here. Now we're going to shift a lambda over to shift of the pink wave. We're going to take that pink wave and shift it 1/2 of a wavelength, so that where the peaks were before, okay, we're not going to have troughs, and where the troughs were before, we're not going to have peaks. So it's going to look like this. Now if we take that, basically we've shifted the pink wave, a phase shift of a 1/2 wavelength. So you get something like this now, right? What the up part now starts over here, 1/2 wavelength away. So the up part now works here, down part, the up part, down part, up part, and because the wave went on in both directions, like that. So what we've done here is taken the pink wave and shifted it lambda over 2, 1/2 of a wavelength. And that leads us from a situation of constructive interference to a situation of destructive interference. Here we have positives adding with negatives, negatives adding with positives. Every step, as we look out along the x-axis, we've frozen this in time. This whole thing is moving, but we've frozen it in time. At every point on the x-axis, here, 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 everywhere, you have a positive and a negative adding up, so that what you get when you add them up is you get 0. Yeah, that is singing a song, isn't it? So you get 0. Here you have destructive interference. Okay, so by taking one of our two waves and shifting it a half a wavelength, we've gone from a situation of constructive interference to a situation of perfectly destructive interference. There's no wave. There are actually there are two waves there, but at every point they cancel out, boom, and give you nothing. And we achieve that by taking one wave, the pink one. We could have done the other one as well. We took the pink wave and shifted it at 1/2 a wavelength, boom. And when we do that, just the relative shift, that's known as phase shift, you get from constructive to destructive interference. And this would have happened, the same thing would have happened whether I shifted it lambda over 2, 3 lambda over 2, 5 lambda over 2, any one of those shifts, right? If I now took the pink and added it and shifted it, another full wavelength, we'd be in the same situation. So basically, when you have a sort of m plus 1/2 lambda phase shift, okay, this is the m equals 0 case, the m equals 1 case, the m equals 2 case, and so forth and so on. Whenever you have a phase shift of lambda over 2, or 3 lambda over 2, or 5 lambda over 2, which is what m plus 1/2 lambda means, okay, for all values of m. If you have a relative phase shift between two waves of this amount, you go from constructive to destructive interference, or from destructive back to constructive interference. Okay, so that's one thing we need to keep in mind. This idea here, as we move forward, and we'll do it within a video or two, we'll actually get to the idea of thin film interference. And you'll see then, this will come back. See the number 1 up here. This is the first of 2 topics we have to touch on before we actually get to thin film interference. Okay, these are prep topics. This is the first of 2 topics, this idea of phase shifts. Okay, and how they can take you from constructive to destructive, or from destructive back to constructive. Okay? All right. So next topic, we're going to talk about what happens to light when it goes from one medium into another.